assisting in our research. Today, I'll be introducing our study, Web-based timespan tree editor and analysis database. The timespan tree is a structure obtained from analysis using a theory of music called the Generative Theory of Tonal Music or GTTM. Abstracted melodies can be obtained by splitting the timespan tree down the middle and omitting notes that are connected to branches under a given line. We have developed tools for a timespan tree, though we encountered some problems. The interactive GTTM analyzer cannot use music scores, and the manual timespan tree generation tool cannot be used at the moment because an OS update made the score display library unusable. Furthermore, the data structure of timespan tree is not suitable for the data format used when displayed on a screen. Thus, we developed a web-based timespan tree editor in which a connection can be established simply by selecting a branch and attaching it to another branch. Likewise, a connection can be deleted simply by selecting and moving the connected branch. We use JavaScript operation notation to define data structures so that they can be displayed in computer programs and are easy for user to understand. We implemented our tool using HTML5, which is advantageous because it can operate on multiple platforms. Our web-based timespan tree editor can be accessed from this QR code. Thank you for your attention.
Hello, I'm Tsubasa Tanaka. The title of my paper is Motif Set Assignment Problem in the Compositional Process of Musical Rally. Musical Rally is a piece that I composed using a method of constraint optimization. I have designed this piece to create a situation that musicians gather and play music together without much practice. This is also to deconstruct the form of concert by replacing the concept of concert with that of meeting or rally. To realize this, I have designed a way of collective guided improvisation. The piece consists of 11 sections, and 4 motifs are assigned to each section. The musicians share the same motifs and improvise based on them. Here, we confront a constraint optimization problem of how to assign the motifs to sections with musical constraints. This is what I call motif set assignment problem. I will explain more about the details in my presentation. And this is an excerpt. Thank you for your attention.
The title is Expectation-Based Parsing for Jazz Chord Sequences. First, visual or motivation. Many grammar theories of music have been proposed compared to language, and thus the syntax has been represented in tree. In the parsing processes, trees are usually constructed by the generative rule given by the whole span of music piece in a top-down manner. In this paper, visual or incremental parser does construct the tree from the left-hand branch to the top, expecting the right-hand branch. This construction is not only for the change of parsing strategy. It is said that we can regard the meaning of music as the expectation process of subsequent phrase consciously or unconsciously. In this paper, we consider music as a dynamic cognitive process and propose an incremental parser that composes a tree from a local phrase of the beginning part to a larger phrase including the succeeding part. In our proposed parsing algorithm, we use 2 charts, the local and the global chart. By using these charts, we can predict the succeeding phrase from the beginning part and reveal the global relation. In sample analysis, we apply a method to George standards represented by chord sequences, implement the parser, and exemplify the incremental generating process step by step. We considered 2 different expectation-based analyses and discussed a methodology that extends the parser algorithm to a broader range of real-world data. Finally, such an incremental method based on cognitive expectation has the potential to be applied to various MIR tasks.
The paper presents the development of a framework for creating augmented reality gesture-based scores in the context of experimental instrumental composition. The notation system is made possible by the augmented reality software Gesturer, developed by me. This framework allows one to draw trajectories of gestures directly on the real vibrating body. The framework is composed by an application developed in Unity for augmented reality and an audio component developed in Max MSP. The trajectories drawn by the user are visualized as line moving in real time with a predetermined speed. The user can also create an augmented reality score, which is visualized as a sequence of trajectories by arranging miniaturized trajectories representations on a timeline. The timeline is then processed and a set of events is created. This application paves the way to a new kind of notation, embodied interactive notation, characterized by a mimetic four-dimensional representation of gesture, where the act of notation performed by the composer during the compositional process corresponds to the notated act, which is the action the interpreter is meant to produce during the performance.
Welcome to Latent Birds. We propose a method to generate original bird vocalizations using an autoencoder. Our solution generates an almost unlimited number of bird vocalizations in real time. These vocalizations can be used for adding sound effects to the film and gaming industries, to television and radio broadcasts, to artistic installations, and for wellness and mindfulness purposes. The setup is simple, and the neural network can be trained in 4 hours. To train the autoencoder, we use 6 hours of bird vocalizations split into 4-second chunks and converted to MEL spectrograms. The autoencoder is not symmetrical. The encoder is a convolutional network, and the decoder is made by fully connected layers. The bird vocalizations are encoded in a 512-dimensional vector, and the output is a MEL spectrogram, which then in turn is converted to audio. Once the autoencoder is trained, the system can generate 40,000 spectrograms per second. 2 methods of generation have been tested: random sampling and interpolation. The autoencoder generates 4 seconds of audio. To obtain longer audios, we can orbit around a point in the latent space. The proposed architecture is very fast to train. It can be used for real-time sound generation. It produces longer vocalizations, and it's simple to extend or integrate into existing workflows. Thank you very much.
Hi everyone, my name is Charles Brasier, and I'm going to present you the work that has been done with Gerhard Widmer at the Institute of Computational Perception in Linz. This work tackled the score following task as real-time audio-to-audio alignment method applied to opera performances, and namely to the Don Giovanni piece of Mozart. In this work, we show that applying the state-of-the-art online time warping method remains inaccurate and leads to severe errors that we analyze. We identify 3 specific sources of problems, and for this, we devise specific audio event detectors that are based on trained binary classifiers working in real time. We propose a combination of a DTW-based music tracker with those detectors that directly halt the tracking process during events that are not thought to be part of the score. For our experiments, we add incrementally those detectors to the baseline tracker. Our results show step by step how those detectors add robustness to the score follower. However, there remain a number of opening problems which we identify as targets for ongoing and future research. If you have any questions, feel free to contact me and I will be happy to exchange with you. Thank you.
Hello everyone, my name is Simon Tyrrell. This is our project, AVAI, a tool for expressive music visualization based on autoencoders and constant Q transformation. As humans encode information from our surroundings to find structure, so does the autoencoder, learning through experience to find structure. The essence of this structure is the encoded information in the bottleneck layer, also known as the latent space. We have built an autoencoder to emulate the human sound perception and visualize the encoded information. This is a replication of the phenomenon known as synesthesia, when a stimulus to one sense creates a response in another sense, a neural short circuit of senses. In visualizing the latent space, It is explored for expressiveness in an experiment with 23 participants. The participants found the visualizations to be expressive, and we found that the update speed, the allowed rate of change between frames, is very important for expressive visualization. The topology of our autoencoder is shallow and cannot handle a temporal continuation of information. This makes the encoding of lower abstraction, which makes it very interesting to explore high abstraction encoding for visualizations in the future. A huge thank you to George Palamas and Daniel Overholt for the supervision of this project. Thank you.
Welcome everybody. We have developed a digital tool that helps us to identify the small rounded 2-3-part form, SRTTPF, in popular collections of songs and dances printed and published in Europe of the 18th century. We want to reconstruct whether the SRTTPF migrates from London to other places in Europe. We use the all-common substring algorithm, a variant of the longest common substring algorithm, in order to analyze a corpus of 3,000 music XMLs. Here, you see the relationship between the matrix created by the ACS algorithm and the visualization of the musical form. The top graph labeled S presents the summary of all individual graphs underneath of the summary graph. This infinite HTML, visualizing the various layers of repeated note strings in the analyzed pieces helped us to identify the criteria that rules the SRTTPF. And, finally, here is a fragment of the music historical interpretation of the computer analytical results. As we have found out, pieces with SRTTPF in London and Vienna are related to each other via the subcorpus of Scottish tunes. The yellow, orange, and red bars present 3 different types of the form. In the late 18th century, English publishers sent Scottish tunes to Haydn and Beethoven in Vienna, commissioning them to arrange the tunes for the English popular taste.
We look forward to talking with you about the project.
In the last 7 years, the Centro di Sonologia Computazionale of the University of Padova digitized more than 2,500 audio documents, both from Italian and international audio archives, mainly stored on analog magnetic carriers such as open reel tapes and cassettes. This paper summarizes the collected data and metadata and compares them for different typologies of audio documents. This information can be precious for archives, audio technicians and policymakers to plan future preservation projects. The digitized corpus consists of more than 200 days of recordings about electronic, folk and other kinds of music, as well as speech recordings. Our digitization methodology was supported by the software PSKit, developed to assist and semi-automate the creation of preservation copies. The methodology provides for collecting numerous metadata about the original carrier in order to preserve contents and contextual information. A remarkable amount of information was collected, and it allowed to identify most common issues, typologies, and usage practice for each type of audio archive. If you are dealing with a conspicuous or even a small audio archive, please feel free to come to visit us. We are looking forward to talking with you, sharing our experience.
Hi, I'm Oliver Bound from UNSW Sydney. This research is presented with Sam Ferguson, Angelo Freita and Deb Turnbull-Tillman across UNSW and UTS. We researched the composition of multi-device systems and our library, Happy Brackets, our development environment for programming those systems. In this research, we're looking at the question of how you make it easy for people to compose and create interactive media works across multiple devices. So our particular interest is in the problem of how to support the programming of spatial arrays of light and sound multiplicities, given a choice of complex architectures and constraints such as processor and bandwidth limitations. Happy Brackets has a number of features that aim to support that, including advanced DSP libraries, simplified network communication, and particularly an interface that enables interaction with a multiplicity of devices, where we can send code to them, check their status, reset them, and remote control them. In this research, we studied a group of beginners working with the platform who had experience in music composition and programming, but not in this context. We observed the kinds of paradigms they worked with when they conceptualized creative work, the time costs involved in various aspects of their work, how they collaborated and the way that our system supported their collaboration, and how they could use parameter manipulation and tweaking to explore their creative works in real time. And those results are all reported in our paper. Please check it out. Thank you very much.
Hello everybody, and welcome to the presentation of our poster with the title The World's First Interactive 5G Music Concert, Professional Quality Network Music over a Commodity Network Infrastructure. This paper is all about network music performances with musicians in different locations connected via the internet. This topic has been covered for almost 20 years. However, the novelty of our paper is the fact that we did it with a 5G network for the very first time, and we did it with professional musicians who were performing as if they were in the same room and having the same requirements to that kind of online concert. We could attract jazz celebrity Jamie Cullum for that particular purpose, and he was connected to musicians in Bristol, in Birmingham, and he himself was in Guildhall, London, performing an online event with an audience. The event could be considered successful. Everyone reported a in the same venue experience, and also the technical details were similar and comparable to cabled Ethernet connections. Regarding further technical or musical aspects, feel free to ask me any questions. Looking forward to it. Thanks a lot for being part of this.